Hi, this is the Polynomials and Number Representation Review. You can think of polynomials in this manner. It's an analogy, so it doesn't actually mean this. It's just a way of viewing it. So here we have constants. Constants we can think of as countable objects. So we have 1, 2, 3, 4, 5. And we have 1, 2, 3, 4 purple ones. Since they're all countable objects, we can add them together. Here we have linear terms. They're one-dimensional. So we can think of it as a stick, a bar, something that's just a long object. So we have 3 blue ones. Let's call it 3x. The green ones are different. Okay, they can have a different length. So we would call this 1, 2, 3, 4. We'll call them y's. So we can't actually add these together. They're not like terms. We put a plus here, but we can't simplify it any further. Okay, we have quadratic terms. If we consider this to be a length, if we take a length and multiply it by another length, we get a square. So we can think of these as square objects. So we have 1, 2, 3. 3 big squares, we'll call them x squared. We have 4 smaller squares. So we'll call them something different. Again, we can add these two together, but we can't simplify it. Okay, if we take a length, multiply it by itself 3 times, we get a cube. So here we have 2 blue cubes, 2x cubed. And we have green cubes, 3 of them. Okay, and that's as simplified as this gets. We can't simplify it any further. You can't say something like 5x cubed y cubed. This is incorrect. So when we're adding and subtracting polynomials, it means we can only add and subtract like terms when we're simplifying. And because cubes and squares are different, we can't add these two and simplify it. And the nice thing about polynomials, it's bedmass still applies. This means we're operating on the same set of rules. We don't have to use new rules to work on polynomials. Okay, we're asked to simplify this. We start with the highest power. And we only have 2 terms. So, minus 4 minus 5 x cubed. This is minus 9x cubed. Now let's look at x squared. We have 2 x squared terms. Minus 7 plus 8 x squared. This is 1x squared. Let's look at the x terms. There's 3 of them. So 3 plus 6 minus 9 x. 3 plus 6 is 9. 9 minus 9 is 0. 0x. And finally, we have the constant terms. There's 1, 2, 3 constant terms. So this is 5 minus 13 plus 20. I said you can move these around as long as you left the signs alone. So 5 plus 20 is 25 minus 13, and that gives us 12. And we write this as one statement. This is minus 9x cubed plus x squared. 1 times anything is the anything, so we don't have to write the 1. Plus 0x, that's just 0. So again, we don't have to write that term. And plus 12. Let's look at multiplying polynomials. And you need to remember, you need to distribute when there's brackets. So for two binomials, this is called foiling, and you need to know your power laws. If we're multiplying powers, we simply add the exponents. If we're dividing powers, we subtract the exponents. And let's give you one more. So if we have a trinomial, a plus b plus c times d plus e, if they were polynomials, you want to do ad plus bd plus cd and add ae plus be plus ce and collect like terms if this was a polynomial. Okay, here's some examples. We can cancel. We're dividing both of these by 3, and we're left with 2. And we're using the divide law, so 3 minus 2. So we have x over 2. Here, this is all multiplies. This minus does not mean minus. This is a negative sign because it's in the brackets. We can multiply 3 times 4, then times 5, or we can multiply 4 times 5, then multiply by 3. If we multiply 4 by 5 first, this gives us 20. Now we're multiplying a single digit by another single digit. So 20 times 3 is 60. If you can multiply by 12s, then go ahead and do 3 times 4 first. That's 12, then times 5. Now we count our x's. We have 2, 3, 4 x's. So that's x to the power of 4. And again, this negative not subtract. Okay, here we have 3 binomials multiplied together. So let's multiply these two first, put brackets around it. FOIL first, 2x squared, outer, 2 times x, inner, minus 3 times 2x, that's minus 6x, minus 3 times 2, that's minus 6. Okay, when you multiply a binomial by a binomial, that's 2 terms times 2 terms. That gives you 4 terms. We don't want to multiply this by this, because this is 4 terms multiplied by 2 terms. That gives us 8 terms. So let's simplify this first. 2x squared minus 4x minus 6. Now we have a trinomial times a binomial. That's 3 terms times 2 terms. So we'll end up with 6 terms. So we have this multiplied by the trinomial. So minus 6x cubed minus 3 times minus 4, that's positive 12, x squared, minus 3 times minus 6, that's positive 18x. Now we're going to multiply the negative 2 by the trinomial. And I'm going to line this up so that the like terms are above and below each other. Minus 2 times 2 is minus 4, x squared. Minus 2 times minus 4, that's 8x. And minus 2 times minus 6 is positive 12. Now we can add the columns. Minus 6x cubed plus 8x squared plus 26x plus 12. And that's our final answer. Okay, this one's simple. It's just a binomial times a binomial. Minus 3 times minus 5 is 15x squared. Minus 3 times 6 is minus 18x. Minus 4 times minus 5 is plus 20x. And minus 4 times 6 is negative 24. Group the like terms, that's only the middle ones. And that's complete. So dividing polynomials, it's a little bit trickier. You need to factor the numerator and denominator fully before canceling. Otherwise, you risk making a mistake. Unless you know what you're doing, this is really not allowed, canceling before fully factoring. It's also good to remember that when you're canceling, the factor becomes 1, not 0 or nothing. We'll see an example of this in a bit. Okay, let's factor this. We can factor a 2 out. I'm going to reorder this so that 2x is first, and then 4 divided by 2 is 2. And we're just going to factor 2 out. So this is 2x plus 2. Now we can cancel. We can cancel the 2's, and our answer is x plus 2 over 2x plus 2. Now, it is incorrect to try to cancel out these 2's. This is not factored. Factored means everything has multiplies between them. There's not a multiply between these, so you can't cancel them out. This is not allowed. Please do not make this error. Okay. Let's factor the numerator. We're looking for factors of 2 that add up to 3. 2x, 1x, that's 3x. Now we're looking for factors of negative 3. Because it's negative, one must be positive, one must be negative. This is negative, so the 3 must be with the negative. Okay, so we have 1x minus 3x, that's minus 2x. Now we can cancel away. And our answer is x plus 2, x minus 3. And just a reminder, we cannot cancel these out. Again, this is not allowed. There's a plus and a minus between what we're canceling. It has to be strictly multiplies. We have a multiply here, so we're free to cancel the whole thing out. Again, we have multiply here, we're allowed to cancel that out. Let's look at the next example. Let's factor a 2 out first. Okay, 2 divided by 2, 10 divided by 2 is 5, 8 divided by 2 is 4. 2. Factor our 2 out, x squared plus x minus 12. Again, multiplies, we're free to cancel this out. Now we factor. X factors of 4. 2 and 2 don't work because that does not add up to 5. So it's plus 4 and plus 1. Factors of 12 that add to 1. We have a positive and a negative. So the positive must be 4 and the negative must be 3. So 4 minus 3 is 1x. And we're free to cancel these out. Again, there's a multiply between. So our answer is x plus 1 over x minus 3. Okay, let's factor this. Again, we have a positive and a negative. And factors of 18, 2 and 9 don't work because the difference is 7. 6 and 3 work. Okay, so it's negative, so the 6 must be the negative. And let's write this as a fraction. And we have x plus 3 in the denominator. Again, we have a multiply here. So we're free to cancel. Our answer is x minus 6. We have a 1 in the denominator, but anything divided by 1 is just itself, so we don't have to write the divide by 1 here. Let's look at this one. We have x plus 6 in the numerator. We're looking for factors of 12 that have a difference of 4. So 12 and 1 don't work. It's a difference of 11. And 4 and 3 don't work. It has a difference of 1, so it must be 6 and 2. 6 must be the positive. 2 must be the negative, because 6 minus 2 is 4. And if you're not sure, you'll always try the free term as your factor, because usually we're looking for something to cancel. So we have x minus 2. But remember I said that when we cancel it out, we don't have nothing. We have a 1. So our answer is 1 over x minus 2. And the last tip is when we're simplifying, if there's a rational and other terms, then you need to convert to a single rational by using a common denominator. And if you're having trouble solving, you can watch the video for the answer key. But that completes this review.